Hey friends, we're going to go over some common misconceptions that work their way in once we've learned notation for the inverse functions of our trig functions. So we're going to start with two random background problems and then connect them and summarize at the end. And again, this really is a great way to avoid misconceptions in the future. I see it all the time with my higher level math students. So let's just look in the upper left hand corner right here. It just says 3 squared, so we know what an exponent is. This is 3 times 3. So we get 9. Then just moving this way to the right to 3 to the negative third. I included that because we know the idea of a negative exponent, which is like move the idea or move the location of the base, flip. There's a lot of different ways you might have remembered it in your head, but we all know this would be 1 over 3 to the third, which would be simplified to 1 over 27. And then the most important one right now is this. So 3 to the negative first power is 1 over 3. And with this special exponent, we've developed this like word called the reciprocal. And I'm making sure to emphasize that because that's an important word, the reciprocal, right? So we just have some exponents, just examples of that. And then we have a specific example that we call the reciprocal. Again, changing directions, this is another random warm up to connect. At some point in the class, we asked, if you were given a function f of x, what would the inverse function be? We have this general idea that a function like f, we just give it a name, so I called it f. It's a really short name. Could call it Gary if I want to, but f is easier. So a function takes in some sort of information. I have to give it something, so we call it the input value. And then whatever that rule does, it takes the information I gave it, does its rules or its operations, and then spits something out, so we call it the output. So the idea of its inverse function, well, let's do an example. So if I said, okay, if I gave the input of 3 into this machine f, it would take it, multiply it by 2, and then subtract 1, and it would give me the number 5. So the idea then was the inverse function should do the opposite, meaning the inverse function should take in an original output and then undo the original function to tell you what the original input was. So for example, if I said, hey, in machine f, if I got out the number 5, what number did I put in? And in that case, of course, it would be 3. And this is our problem. This right here, which we have used, and we have a very good word for it, right? We call it the inverse because it's super important. We have now just used that symbol as 2 different words. See how this looks exactly how it looks down here. Up here it's called the reciprocal, and down here it's called the inverse. They are significantly different things. But then when it comes to using trig functions, the idea of how we've developed that complicates a little bit more. So let's think about something like the sine of 45. And let's just say we're working in degrees. I'll even clarify it more by putting a parenthesis around the sine of 45. What does this mean? Well, first of all, we know that the sine of 45 is root 2 over 2. So what does this mean? Well, that could be commonly mistaken, right? Do I mean the sine of whatever 45 squared is, which would be the sine of 2025, which if I really had to figure out in degrees, that would be negative 0.0707, so it looks like negative root 2 over 2. So you have that frame of reference. So that, or do I mean this? Do I mean take the sine of 45 and square it? Which would be something way different, right? If I took root 2 over 2 and multiplied it by root 2 over 2, I get a half. So working with exponents is confusing. So what we've decided to do with trig functions is if I want to put an exponent on a trig function so that I don't confuse my reader whether that operation is done to the input value or if I want to do it to the output value, what we've agreed upon, or what you will almost always see moving forward, is we write it like this: sine squared of 45. This means I want to square my output value and not my input value. So let's keep all of this straight and summarize what I'm trying to get at here. Let's just look at sine as an example here. If I do this, this is the inverse sine of, so I'm using it as an inverse. Any other number, like 2, any other negative number, I could put -3 there if I wanted to. Again, any other number, this is an exponent. So in other words, what you would think about is using another grouping symbol. I'm sorry. So those are equivalent statements. Now, if you want the reciprocal, you'd have to write it as an exponent in this form. So the reciprocal I have to write that as the sine of x with an extra grouping symbol. So I'm clearly flipping the output and not the input. I'm just trying to introduce it to you early so you can kind of keep track of those things. So make sure you're paying particular attention to how you're writing things, especially pay particular attention to how you're using it on your calculator because of the buttons and all that good stuff. Now, the last idea to add to this is there is an alternate way to be writing the inverses. So for example, like if I was thinking about the inverse tangent of some input value, the alternate notation is called the arctangent. So those are equivalent statements, and it works for all of the trig functions, like the inverse sine. Like to me, when I do calculus, I just write the arc sine of x. It just removes the ambiguity of the number, and it also just reminds me more explicitly that's the inverse function. The same thing with cosine, and I'm going to stop writing them after that. But same thing would apply with secant, cosecant, and cotangent. And just as a quick reminder, like how do I remember that? It's not necessarily like the way that you would have to, I guess. But this is what I remember when I see those word arc as an indicator for the inverse. And I'm just going to use cosine as an example. So when I think about the cosine function itself, it takes in some sort of angle measure. And then it's measuring a ratio of sides. I'm just going to call it a ratio of sides. So then by definition, its inverse, as we know, it just simply flips the inputs and the outputs, right? So it would take in a ratio of sides, and it would tell you the angle measure. Now, the way that I remember what arc cosine or arc sine or anything like that means is I think about this problem on the unit circle. So if I was going to do, and I'll just highlight this in orange so you know what my orange picture is about. Here, you have to know the angle first. So I'm imagining drawing an angle. So I'd have to say, okay, well, what angle am I putting into the cosine? And then just for something like simplicity, let's put in 45. So be like, okay, well, in order for me to tell you the answer here, I'd have to take this, I'd have to accumulate 45 degrees. And then once I've drawn this, once I have the angle, then what I want you to see is I know where I am on the circle, right? So I can like draw that and I can measure all these ratios. Now, when I think about going backwards from that, and this one I'm just going to highlight in purple so you know where this picture in purple is coming from. Now, when it's coming in purple, the idea of the inverse cosine is I've given it some information first, and it's supposed to tell me the angle that I originally used. So the way I think about that, if I'm thinking about making an angle, rather than telling you a ratio of sides, I could tell you how much of this circle, how big of an arc I have cut off from that circle. So if I told you I used this much, this big of an arc, what angle was that? Oh, that was a 90-degree angle. So it would tell me the answer was 90, right? And that's why I just remember using the arc cosine as an inverse or an alternate notation for the inverse.